Welcome to the second test review, or part 2 of the test review. Again, this is for Physical Science 2, Learning Set 1, so this will be the first test. And I broke the review down into two parts. So this part of the review starts out with question 7 or statement 7 or number 7. So if you look on the paper copy of the review, basically what I did was took that review sheet and I put it here in a notebook file, and then I just use this to explain the answers and go through them a little bit more thoroughly. On the review, hopefully you have lots of copies, or not copies, but lots of notes on it, so you can use that to study for the test. So what I would recommend is always taking good notes and then watching these videos a day or two before the test. Highlight things that you still have questions with, bring them in, and ask your science teachers. So the first question here is number 7 on the review. And it says, be able to identify if energy is being converted or not. Use the following examples as practice. So one of the things you're going to have to be able to do on a test is just be able to explain if energy is being converted and what types of energy is being converted. So here are some examples I put down. Now again, these aren't going to be the exact answers or questions that are on the test, or I'm not going to have you go through, and number 7 is going to be number 7 on the test. But if you can answer these questions right here, or statements, not really questions, if you can do these things on this review, and if you watch the review and say, oh, I know that, oh, I can do that, yeah, you're doing well. One of the things you might want to do is just pause the, now that you know what you need to do, pause the video, go through and answer these yourself, and then replay the video and see if you got it right. So, be able to identify if energy is being converted or not. So if you were to take a rubber band and you were to stretch that rubber band and you were to shoot it at someone, stretching rubber band and letting it go, is energy being converted or not? So what's your answer? If you said yes, it is, you're correct, yeah. So when the rubber band's not being stretched at all, it's not no movement, so you have no energy, or at least it's just sitting there. But once you start to stretch it, you've got that elastic energy, and then when you let it go, you've got kinetic energy. So yes, definitely energy is being converted. Playing with a yo-yo, what do you think? If you answered yes, you're correct. Because that yo-yo, as you're doing it, it's going up and down and up and down and up and down and up and down. So there's definitely kinetic energy involved as well as gravitational energy. How about a book sitting on a desk? So if you just had your desk, ooh, sorry, that desk is crooked, but just pretend now that it's straight. If that desk is just sitting there, not moving at all, is energy being converted or not? What's your answer? Should be no. You might say, well, it's got gravitational energy because it's not on the floor. Well, if it's sitting on the desk, that is the lowest level it can go. So if it's sitting on the desk, no, it won't have any gravitational energy. How about dropping a ball? If you answered yes, you are correct. Because when you're dropping it, the GE is decreasing, kinetic energy is increasing, because as the ball gets dropped, it should be picking up speed. So, any questions on this and being able to identify if something is being converted, or if energy is being converted or not? Now, you notice it says if energy is being converted. On a test, I might ask you, okay, what is actually being converted? And that's where you're going to have to talk about those things. In fact, that's the next question. What type or what energy type is represented in the following pictures? And number 9, which type of energy conversion is involved when the arrow is released? So those are the things that you have to be able to do on a test as well. So not only is energy being converted or not, but what energy conversion is involved, or what energy type is involved. So what energy type is represented in the following pictures? So you got a slingshot here, and you got a bow, an arrow here. It could be, it doesn't look like a compound bow, so it's a regular bow. So what do we have there? What energy type is being represented? You guys know? If you said elastic, you are correct. Yeah, that's elastic energy. That's one of the energy types that we talked about. on the test. And number 9, which type of energy conversion is involved when the arrow is released? So once that arrow is being released, what's happening? Well, you've got your elastic energy. Let's call it EL. If you got your elastic energy, it's being converted to what? Is it being converted to GE? Well, you could make an argument for that, but that's probably not the best answer. So if you said KE, you're correct. I think that would be the best answer, because right now, if this arrow is sitting right here and it's not moving, some might consider that to be the ultimate base level. Now, once you release it, you've got kinetic energy, and as the arrow slows down and it starts to fall, after it's being released, that kinetic energy will change to GE, or that you'll have some GE and it'll change to KE. But once it's sitting here, I'm not sure if you consider it to have any GE at all. But once it's released, then it has GE. So which type of energy conversion is involved when the arrow is released? The best answer would be you have elastic energy and it gets converted to KE because it's starting to move. Now, one of the other things that we started to do with the physical science book is we started to create energy conversion diagrams. And you are going to have to do one of these on the test. Now, one of the things I will tell you on the test is that it will not be something that's brand spanking new like you have here. It will be something that we've covered in class. I'm not going to tell you exactly which one, but you need to feel comfortable creating these. So if you're still not comfortable, if you still don't know how to create an energy conversion diagram, make sure you ask your teachers before the test so that you can get some help. So be able to create an energy conversion diagram. Now I will tell you this, on the test, you're only going to have to go between KE, for this first test anyway, and GE. So what I'm going to do is I'm going to say KE is going to be dots and GE is going to be solid lines. So here we have A. Oops, sorry there. We have A. As it's going up, what is happening to the amount of kinetic energy? Does it have more kinetic energy? Does it have less kinetic energy? How much GE does it have? And then you have B. Then you have C as the ball is going down. So perhaps B would be the easiest. As this ball is going up, what do we know actually happens at B? What happens for a split second as that soccer ball goes up, reaches its apex, and starts to fall? For a fraction of a second, what happens to the amount of KE? It completely disappears. You're correct. So I'm going to say B is entirely GE. So I'm going to make a scale. I'm just going to do the whole thing. It's 100% because for that split second it stops. So as we get here and here, how do we do these? Well, here we know that GE is decreasing. Now, this is, if we did this and we did this, we know that this is almost 50%. So I'd accept if you cut these circles each in half and you said, okay, here are the KE is here, and here's the GE, that's A, B, and C. And then maybe here you're going to flip them. And what that would tell me is that when I look at A, B, and C, because we know that's the order from the diagram, I know that the amount of kinetic energy is decreasing to the point where it has none in B, but then all of a sudden we get more, so it's starting to increase again. And I know that's what's happening. As the ball goes up, it's getting slower and slower and slower, so the amount of KE is decreasing. As it gets higher and higher, the amount of GE is increasing to the point where at its highest point, and there's no motion, you get all gravitational energy. So you're going to have to be able to do something like this on a test. And it might be a little bit more complicated. You might have a few more, but just understand a relationship between kinetic energy and gravitational energy. That's really the bulk of this entire test. So as always, if you have any questions, concerns about this review, just ask your teachers before the test. Not the morning of the test, but before the test. That way you have plenty of time to get ready. So thanks. Bye.